So 1 is a metal plus acid, right? So if we have, give me a name of a metal from the reactivity series.
Give a metal, iron.
Potassium.
Iron, right?
Calcium. Gold.
I don't want gold, because gold don't react with acid, right? Magnesium. Alright?
Potassium.
Plus HCl, AQ. Remember the state when you're doing the exam, you have to put the physical state, right? In the form of magnesium, says in the form of salt plus hydrogen. So this is magnesium chloride to gas. So one magnesium, so 2 chloride, 2 hydrogen, so we'll just put a 2 here. Alright, so remember the syllabus requires you to know the reaction between the metal plus hydrochloric acid or sulfuric acid. So let's just interchange them, alright? So if we put this plus H2SO4 AQ,
Right, just
this is sulfuric acid.
sulfuric.
Yes, it's gonna produce calcium sulfate, which is the salt, plus hydrogen gas. Remember, all of this is metal plus acid produce salt plus hydrogen. That's the one I was focusing on, and give you some examples of. Iron reacts very slowly with acid, right? So if we go HCl here, hydrochloric acid, will produce FeCl2 plus hydrogen gas. Right, so if we balance it, we have 1, 2 here. Balance, right? That's some example. The second one was metal plus what?
Metal plus oxygen. Metal plus oxygen.
Produce what?
Metal oxide.
Alright? So the examples now.
Metal.
Yes, again.
Aluminum.
Al, solid, yes.
Calcium.
Come on, use different metals from up there. Sodium.
Sodium.
We know the potassium and metal.
Potassium.
Potassium.
Yes, potassium. Good. Alright? Now, so we know how we came up with these formulas, right?
Yes.
Yeah. Molecule of this.
Iron is 2 plus, it can be 3 plus as well, but iron 2 plus, calcium 2 plus, magnesium 2 plus. So chloride is 1 minus, so that's why we have FeCl2 here. Because the chloride was a 1 minus, iron is a 2 plus, so it's going to need 2 chloride ion to form the compound for the charge to be neutral.
Okay.
Remember, the compound have to be electrically neutral, you know. So the charge and the cations have to be equal to the charge and the anions.
Because the Cl is a negative.
Yes.
And the iron is a
So it's 2 minus. So each Cl is a minus.
So you have
Iron is a 2 plus.
You have a job 2 on that. And,
Yes.
and the iron will be 1.
Good. Oxygen gas plus oxygen gas
That would be 1.
plus oxygen gas. Alright, so what would be the formula for aluminum oxide?
Formula? It will be
Aluminum is 3 plus, oxygen oxide is minus 2.
So it will be
So it would be Al2O3, solid. And all oxides are solid. Alright?
Yeah, aluminum is
Good. So how do we balance this equation? Remember that in the exam when you're writing that equation, you're going to get a mark for the correct formula for the compound. You're going to get about a half mark for the the physical state, and you're going to get a half mark for balancing the equation. So you have to have all those stuff correct, right? So when you're writing the equation, the formulas of the compound have to be correct. You have to put the plus sign between the reactants and the plus sign between the products, and you have to put the arrow between the reactants and the products. Those are general principles of writing the equation, right? So we put a 2 in front of the aluminum here, 2 aluminum, and then what do we put in front of the oxygen?
So we have put. Okay, I put
Oxygen.
Suppose I have 3 of them. So can put 3 over 2.
Then with that one trick in there, you put the 3 there on the yeah, then times it by the whole equation by 2. So this would cancel this.
Oh,
This cancel this.
alright.
And then it times the whole equation by 2.
Alright. You can work that way as well. Alright? Now what about sodium plus oxygen?
sodium plus oxygen.
Produce of the formula.
Na2.
Yes? Oh.
Oh.
Why? You're following Harding?
Yeah, I think so.
Well, we have the 2 here and
Oxygen is actually 2, right?
minus 2.
Minus
Sodium
two,
is
the
plus 1.
interchange them.
Good.
Put the sodium at the oxygen and
Good. Alright. And then finally the potassium, same thing here again. K2O. Solid. Alright, you can take these and then next we're gonna have metal plus water liquid. The liquid form, right? That's LA water liquid, right? It's gonna produce metal hydroxide
Plus hydrogen.
right? We're just using 2 examples in this case, right? Give me 2 metal.
2 metal.
And go potassium and we can go magnesium, alright?
We can do.
So this is plus H2O liquid plus H2O liquid. Metal hydroxide, so this is gonna be
K2.
KO plus H2 gas.
That will be same thing.
Oh, this is, sorry, hydroxide, OH.
Hydroxide.
How do we balance that equation?
How do you balance it? You put the 2. You put 2 in front of the hydrogen. And put 2 in front of the K. You put 2 in front of the KOH in a metal hydroxide, the KOH, 2 in front of the KOH, and 2 in front of the hydrogen, in front of the water, and 2 in front of the K.
2 in front of the potassium and 2 in front of this?
Yes. And 2 in front of the water.
Sure?
Yes.
So this is what?
Because
Two.
it's H2.
Four.
It's 2, 4, yeah.
2 oxygen, 2 oxygen. Alright, good. What about magnesium and water? So it's gonna be magnesium oxide, hydroxide, sorry. What's the formula for magnesium hydroxide?
Formula for magnesium hydroxide. Mg.
The Mg2, MgOH2.
Yeah, but that's a bracket the OH, right?
Plus H2.
They never bracket it up at the top.
Plus H2.
Here?
Plus,
Because it's 1.
Okay.
plus H2 and the water 2. 2 in front of the water.
2 in front of the water.
Yeah. Because it's 2.
Four. Alright, and then that balance. Good. Alright, so final steam, alright? Water vapor produce metal oxide plus hydrogen. Yes, alright? So we go like plus H2O gas. Well, it's water vapor now, so the gas is there, right? This is going to produce ZnO solid plus hydrogen gas. And that's balanced as it is, it seems. Alright? So there it is. Same thing, we could use magnesium, same thing, or potassium, just much. Alright? Alright. So, I'm going to write about the reactivity. So it's potassium, sodium, group 1, calcium, magnesium, group 2. Then you have aluminum, group 3. Then you have zinc, copper, silver. So Ag is silver. Right down? No. So when you look at the syllabus is going to require you to know how reactive these metals are with hydrogen. Hydrogen, oxygen, and water, right? So it's going to be acid, alright? So group from potassium to aluminum with acid, they basically
Reactive, most reactive.
vigorous. They use the term
Vigorous, most reactive.
violent or vigorous, right? So violent,
Vigorous, active elements. Vigorous, reactive.
basically, alright? But we know that the potassium would be like most violent, then this is like violent, then this is fairly violent, etc. coming down, right? So we have to know that, but in general, all these group 1, 2, and 3 metals, they will react very vigorous, so they basically will even catch fire. So sometimes when the reaction is taking place with the acid, if you go on YouTube and video it, you'll see that, yes, like the reaction is taking place, actually the hydrogen that is being produced. Because remember that the acid, the metal will react with the acid to produce the metal hydroxide. No, the salt, sorry, it will react, so the acid is going to react with the metal to produce the salt plus hydrogen gas. This hydrogen gas that is produced in these reactions that are reacting so violent and vigorous, it means they are exothermic. Sometimes the hydrogen that is produced will just ignite and burn, and you will see the fire there. So you can go and research it and you will see.
That would have a blue or
it depends on. It depends. Alright? No. So iron, what is iron here? Zinc, iron, copper, sorry. Zinc, my bad. So iron should be here. Copper and silver. Alright? So the zinc and the iron, they will react slow. Basically.
All that you want to put in, sir?
No, I don't put in everything, I just write in the general trend.
General.
Alright? This is slow, and this is
medium.
no,
Monetary.
purely
Monetary.
the fairly vigorously for this.
Fairly vigorously. That's all that I agree then.
Yeah. Right? Well, copper and silver, no reaction, right?
Copper and silver, no reaction.
This is the general trend for the acids, alright? Now, in terms of the burning oxygen, so the sodium, the potassium, they burn vigorously, alright? Alright? The magnesium, calcium, they burn easily. The last two, they don't burn, so does not burn. And the next three there, they burn when heated strongly. Okay? I'm just trying to use a broader category than that's what's in the book, so it's easier to remember. Alright, and basic idea. Okay? However, when we move on to qualitative analysis, you will have to have an idea of the color. We can save it for qualitative analysis and the color in which these metals will burn in oxygen. Right? For example, like the potassium, we call like lilac, I think it's a pale purple color. The sodium is orange, the calcium is brick red, and the magnesium is white. Alright, so the reaction with water down to magnesium, they react vigorous. Alright? Down to magnesium. So the calcium moderate, sorry. Our calcium is moderate, right? So vigorous, this is moderate. Alright? And as we know, as we move down the last two is always basically no reaction, alright? So you can use down that the top ones in general they react very fast, the bottom ones tend not to react.
And for water, for zinc and what else? Fe is that? Sulfur.
You're saying that iron will react with steel. Alright, so this is a general trend for them. Alright? Now, we're going to move on to some reactions of metal compounds is also in the syllabus. So we're going to look at the reactions of metal oxide, metal hydroxide, and metal carbonate with acid. Alright, so that's the next set of reactions that we're going on. Alright, you have this general trend. So remember, here is not really to SWOT, it's just to, that is why I gave you the acronym to remember the reactivity series, right? So just to know that whether it is acid, oxygen or water, the metals at the top, they are extremely reactive. We normally say violent, they react violently, meaning they will even catch fire, or vigorously, meaning they react very, very fast. Alright, so as you should mix the metal with the acid or the water, the reaction will actually be going on and the hydrogen gas actually is being produced. Alright, you can see even then sometimes like the smoke and stuff, and it will catch fire in most cases. Well, if you should put a piece of copper or silver in water or acid, it will just stay there and no reaction will take place. Alright, these are stuff that you have to remember. Alright? Some metal compounds with acid. Alright? And we're talking about the hydroxides, the oxide, and the carbonate. Alright? So, reactions of metal oxide and dilute acid. Alright? So one metal oxide plus acid. General first now, as usual. Alright, let's just put examples and general at the same place this time. Alright? So metal oxide plus acid produce. So it's an acid and a base produce. Salt and water. Right? Because in truly, metal oxide and metal hydroxide they are base. Even though we have to cover acid, bases and salt, but you can get the introduction from here. Alright?
And hydraulic acid, so
Good. And metal hydroxide plus acid produce salt and water, right? While metal carbonate plus acid, what do we produce here?
salt and
Carbon dioxide plus water.
carbon dioxide.
Alright, and then if we know the general stuff, then we should be able to just pick a metal, pick a acid. So remember that the acid that we're mainly using for the syllabus is hydrochloric acid or sulfuric acid. So you have to remember those two acids and know the formulas by heart. Alright? So give me an example of a metal oxide here.
Metal oxide. Aluminum.
So two examples I'm going to use for each of them.
Sodium.
Aluminum.
Sodium. Aluminum.
What's the formula for aluminum oxide?
Al2O3.
It's solid.
Solid.
Plus which acid we're going to use?
The acid.
The sulfuric or phosphoric acid. Which one do you want us to use?
Sulfur.
Sulfur.
H2SO4. So remember, this is not swatting it. That is why I'm just writing it from, let us make up the equation to ourselves. Because you have to understand the general principle so you can use it in the exam and not swat them. Alright? To produce a salt, what would be the salt from these two?
Alright, the salt is going to be Al2OH.
SO4.
OH.
SO4.
AlSO4. What do we put here? So sulfate is 2 minus, aluminum is 3 plus.
3 plus.
So it's gonna be a 2 here, bracket 3. AQ plus H2O. How do we balance this?
How do you balance it? So you balance already?
If it's balanced, you can say it's balanced, you know, or if it's not balanced, it's not balanced.
Oh,
Two
the water now, so 3 in front of the H, in front of the acid.
Please don't choose, if you're supposed to make up an equation exam, please don't choose this one, alright? And it's hard.
No, but the balance already, sir, to me.
So it is, so the aluminum, 2 aluminum, 2 aluminum.
Balance already, to me, sir.
2 hydrogen, 2 hydrogen.
Oh, 1 oxygen.
This is 3 sulfur, so you need at least a 3 here. You know?
3 sulfur.
No, man.
3 sulfate, this is now.
Okay. Yeah, 3 sulfate. So you have times the whole equation and change up everything.
Yeah.
So where's the 3? You have 6 hydrogen, right?
Yeah.
You have 6 hydrogen.
So 3 you put at the water then.
6 hydrogen.
3 at the water. And the 3 in
I
front of
think
the
that's
H.
why that.
The 3 4 is 12. 3 4 is 12 plus 3. So I have to put that 3 here.
Yeah,
For the oxygen.
And water is liquid here. Alright?
So yeah, when I have 3 hydrogen, 3 times 2, 6. Oh, you have the hydrogen. So, oh, yeah, balance.
Alright. One another example, like easy example is that look like magnesium oxide
Magnesium oxide.
plus 8Cl. What's the salt that is produced here?
Magnesium chloride.
Magnesium chloride.
Plus water. So 2 in front of the HCl, in front of the hydrogen, in front of the acid.
So you have 2,
And that's it.
That's it.
yeah.
Alright, so metal hydroxide plus salt now. So this is like titration, like so base. Let's just use one example of this. You can so use potassium hydroxide plus 8Cl. Easiest one, right? Just want to do something easy, right? To produce what's the salt here?
Minus
Calcium.
Calcium, this is
No,
potassium.
Potassium
chloride.
chloride.
Potassium chloride in water. H2O.
Liquid. Alright, and then I think that's no, yes, it's balance.
Is it? Yeah, that's it.
Alright. The carbon, no, let's write 2 examples of the carbon, please, since it's we're not gonna do a lot of acid. We're gonna look acid bases and salts, and we're gonna do a lot of these equations, alright? Carbonate, so MgCO3 solid plus 8Cl produce what? Salt, carbon dioxide, and water. So the salt is
Chloride
MgCl2
plus
CO2 gas plus
water.
water. Alright?
Balance it out now. So I will put 2 in front of the acid. I will put the 2 3 in front of the CO2, 2 over 3. Because the 3 carbon and
No, but no, this is carbon dioxide. I think this is 1, 2, 3 oxygen. Over that 3 oxygen.
Oh,
It's
3
balanced.
oxygen.
Alright.